All right, so this is for surface area. So in the past, are you guys ready? In the past, we were looking at volumes of revolution, right? That's what we did a review for yesterday. You guys are having lots of side conversations, and it's a little frustrating. All right. So volumes, previously we did volumes of revolution. Oh, I-O. Which is the volume of a solid formed by revolving a curve around an axis. So that's what we did before. We had the disk method, we had the washer method, but you take a curve and rotate it around, and that would make a solid, right? That's what we did before. So what we're doing now is we're going to take those solids and we're going to find their surface area instead of their volume. Right. So formed by revolving a curve around an axis. So now we're doing surface area of revolution, which is the surface area of those solids.
Bless you, buddy. You're welcome.
Bless you too, Zach. Bless you too. All right, so surface area is 2 pi times the integral evaluated from a to b of r multiplied by the square root of 1 plus the derivative squared. So how is this similar to last night's video? Yeah, this whole part is the same as when you find the arc length. So the only thing that's different today is we're adding a 2 pi in the front and we're putting an r right here. But the formula is real similar. Yeah, I'm going to be real honest with you. I have no idea. Well, maybe 2 pi r multiplied. Oh yeah, because this is the area of the base sort of thing, right? Area of the base times like the height. You guys seeing it? Volume. Volume is area of base times height. The area of the base, if you rotate it around, it makes a circle, right? So think about your revolutions, right? Area of the circle, right? So you have the area of a circle multiplied by the height of the figure, and this is the arc length, so that's the height of the figure. You're just kind of doing it sideways instead of up and down. Well, that's fun.
So is that it?
No, I just made the connection and I didn't know it before. All right, r is the distance from the curve and the axis of rotation. So distance from curve and axis of rotation. Now what I said when we were doing the video last night with arc length was that if you're doing this part underneath the square root sign, it could be in terms of x or y and it would still work. Now for what we're doing today, this r value only works if you're in terms of x. So we're going to say always in terms of x. And that's important to remember because that's the part that will mess you up if you forget. So it's just always going to be in terms of x. So if we are rotating about the x-axis, let's say we've got some curve right here. If we're taking this area right here and we rotate it about the x-axis, then the length of r, if you guys can see that these lengths are actually y values. Does everyone see that? Those links are up and down. Those links are y values. So I'm going to say r equals y, but r is not allowed to equal y, right? Now, whenever you're given functions, you're typically given y equals some formula, right? And the formula that you're given is usually in terms of x. So instead of using r equals y as in the y value, we're going to say r equals the curve. So we can't use this because it has a y, but if we use the part that's in terms of x, then we're okay. So it's just going to be like, if the original problem of this curve was like, I don't know, say that's like x squared plus 5 or something, then instead of saying r equals the y value, you're going to say r equals x squared plus 5. Okay. Does that make sense? How you choose your r? You're just using the curve itself. Okay. The other, or it could be other horizontal lines, right? It doesn't have to be the x-axis, it's just other horizontal lines. And then over here we could have about the y-axis. So we're going to look at the same picture here, but this time we're going to rotate it about the y-axis. And now if you're looking at the distance from the curve to the y-axis, you can see that this for r is going to be the x value. Can you guys see that? The distance is the x value, so we're going to say r equals x. So here, your lines were the y value. Over here, your lines are the x value. So that's the part you have to remember because in my opinion, that's like the hardest part of it, since the rest of it is just like Berkeley. Okay. You guys ready to do some examples? No. Favorite. Yeah. All right. Example 1. Find the surface area So find the surface area of the solid that's formed by revolving f of x equals x to the third on the interval from 0 to 1 about the x-axis. You guys remember what the curve y to the third looks like? Yeah. Mia like immediately did Egyptian hands. I like it. So from 0 to 1 would be like this part right here. And the r value is the distance from the curve itself to the x-axis. So if you can see that distance from the curve itself to the x-axis is going to be whatever the length of your y-coordinate is. And we're not allowed to use y. So it would be the y-coordinate minus 0. That would be your distance, right? Because whenever we're finding the distance between something and the axis of rotation, we just subtract them, right? So this is a top minus bottom sort of thing. So we've got y minus 0, but we're not supposed to use y, so what should we write instead? Yeah, the curve minus 0, which is x to the third. So x to the third minus 0, that's our r value. And then we have f of x is x to the third, so f prime of x is 3x squared. All right, and now we are ready to use our formula. So surface area is 2 pi, and we're evaluating the integral from 0 to 1. R equals x cubed. All right, and that is ready to plug into a calculator. So let's plug it in. Let's just make sure that we were typing all our parentheses. I am not your human calculator. I am not your human calculator. You better be typing it in.
Not funny. System back.
So make sure you've got it all typed in correctly. I want to make sure we can get it. James Betts, what was that you just said?
4.107.
Oh. And then what did you say after that?
I said, oh crap.
I don't think that's what the video heard.
I said, oh crap.
5.6 what meters
So
cubed?
this was mom.
Or units cubed?
It's surface area, so the units cubed or square. Units squared.
What's in my parentheses in
Okay.
You didn't, it's just the 3x squared.
If you put units, if you put parentheses around everything, that makes sense.
Sometimes putting too many parentheses in these actually makes it harder to keep track of the parentheses. Alright. How did we do? Were we able to type it in? Yeah. We typed it in, we got it? Okay. What I want you to do is take this. I want to make sure that we can get our exact answers. So what about this is ruining this right now that's making it so we can't have exact? Well, it's decimals. I'm not going to be able to turn this into a fraction. What's ruining it? The pi, right? The 2 is okay, but the pi is wrong. So I'm going to go ahead and plug this back in and delete that pi, because that's keeping me from being able to write an exact answer. So if I want this to be exact, I got that decimal now. I'm going to turn that into a fraction. Oh, that should have worked. I did it earlier. Huh.
No exact answer.
No, it worked. I did it earlier when I was getting my notes ready. No, I definitely just took out the... Did it work for you guys?
No.
Anyone try it? Didn't work for anyone?
Let me try. I took out the pi and then I took out the pi 2. I didn't get it.
Oh, it's the next one. I'm sorry. That's my bad. It's the next one you can do that on. So this one you can't get an exact answer. My bad.
So when
My bad.
you can do it.
So we can't just.
We'll do it on the next one so you guys can see how to do it. This one didn't work. All right. Example 2.
So there's no answer.
There's not. You can't write an exact answer because even when you plug in the numbers, the pi didn't ruin it. It was just ruined on its own. All right. Find the area of the surface. When y equals x squared, from 0 to root 2 is revolved around the y-axis. So 0 to square root 2, and it's being revolved around the y-axis this time. So the distance from this edge to where you are spinning it around the y-axis is going to be an x value minus 0. Oh, gosh. Is that the right? So, and then y prime is what? 2x.
How do you get x minus?
Because the distance of the x coordinate to what I'm spinning it around. So it's the axis, so it's minus 0. So it's the x coordinate minus 0, this x coordinate minus 0, that x coordinate minus 0. So the surface area is 2 pi 0 to root 2 of x times the square root of 1 plus 2x squared.
Sit back, relax. That's my shit.
Okay, now this, did you get it? Yeah. Now this one, if you want the exact answer, you can type it in again without the pi, and it will actually give you an exact fraction.
4.3333.
So that's 13 thirds,
13 pi, yeah, there's
and I'll go back and put the pi in. Good. So exact answer is 13 pi thirds, approximate answer 13.614. And then since this is surface area, if they gave us units, we would say whatever the units were squared. This is area.
But do I have to keep writing unit square?
No.
You don't?
No, I'm okay with you guys not. Typically when people do problems on coordinate axes like this, they don't usually put units. But it's good to remember what the units would be in case you do a square problem. Yeah. Okay. That is it for our examples.
Hey, oh my God.